My name is Luciq AI. I will be the moderator for today's webinar, Key Metrics to Monitor for a Successful Mobile App Release. I would like to introduce our experts for today's webinar, Anwar and Magdoob.
Hello, everyone. So my name is Ahmed Anwar. I'm a senior product manager here at Instabug. My main focus here is on managing and building mobile performance monitoring products, especially products that is focused on metrics that measure latencies and speed of mobile apps. Before Instabug, I used to be a software engineer, and I had my own software house where we used to build mobile apps. So I really know how it feels to release a poor quality app and how frustrating it is to figure out and actually work on improving the performance overall. So I'm very excited for this webinar today, and I hope that you find today's talk beneficial. So Magdoob.
Hi, everyone. Thank you, Anwar. I'm Magdoob. I'm a senior product manager at Instabug. My main focus at Instabug is on the crash reporting product, where we focus on the stability of mobile apps. Before that, I used to work at different enterprise SaaS companies. Hopefully, you'll enjoy this webinar with us today. So the goal of the webinar is to, when you release an application, is to know what are the main metrics that you have to look for to make sure that you have a stable release and all of the customers are happy. Now let's begin. Today we'll talk about three things. First, the agenda. We'll talk about then versus now, which is the state of mobile apps back then versus now. What's changing? What are the new trends that are going on? After that, we'll talk about the top key metrics that you need to look for when you're releasing a new application. What are the important things to look for? And finally, we'll talk about if you have a lot of metrics, what is this one metric that you need to look for to have a stable release? And finally, we'll go over our Q&A. Let's go over the then versus now. So if we go back 10 years ago, the state of mobile apps was very different than now. 10 years ago, if you ask a developer, what did performance mean to you? For them, performance meant only one thing. Performance meant a very good crash-free rate. A crash-free rate means that if you have a lot of sessions, if you have the crash-free rate as 100%, this means that your users did not face any crash, which is a very good thing. So developers wanted to hit a very high number there. This is an important metric for stability, and it's still a very important metric to this day. One of the things that made this metric important is that there is a correlation between the app rating that you have versus the crash-free rate. One of the most important studies that was done to correlate this, it showed that if you want to achieve a very high app rating, let's say it's 4.6, 4.7, or even 5, to achieve this number, it's impossible if your crash-free rate is below 99%, because 1% of 1 million users, that's a big number of people that would be unsatisfied and would write bad reviews. This is when it comes to crashes. But now everything has actually changed. It's not just crash reporting. The state of the whole mobile development has changed. We'll look at 4 things that are trending. We'll look at the customer expectations or user expectations, the operating system. I mean here, iOS and Android, are they doing any more or more additional restrictions? The landscape, the number of applications that are active versus the competition. And finally, we'll go over the App Store optimization. The App Store optimization is the part where you want to land a very high place when you search for a specific keyword on the app or Play Store. For expectations, things have actually changed a lot. If you look back then, 10 years ago, it was okay for a user to have an app launch that stays for 3 or 4 seconds. As a user, you will be happy because the internet was slow. This was the state of mobile apps. But now, if something like this happens, it's very frustrating for you. Let's look at some numbers to see how frustrating is this. So what we did is that we got like the latest numbers when it comes to stability, and we'll share with you what are the user expectations. Let's say your app consumes a lot of battery. You developed an app, it's very good, it has a very good experience, but it's consuming a lot of battery. If this happens, what percentage of users do you think will be unsatisfied and will actually remove the application? The percentage is quite high. It's 36% of people will stop using your app completely if it consumes a lot of battery. Let's look at app launches, for example. If you have a slow app launch or an app launch that's more than 2 seconds. More than 2 seconds, it sounds like a small number, but actually this survey, which was on thousands of customers, it showed that if your app takes more than 2 seconds to load, 40% of users will consider it as a slow app, and they will compare you with other competitors. This is when it comes to app launch. But if your app is unstable overall, when I say unstable, I mean like it has crashes, it has hangs. Overall, when you say like this app is buggy, if your app is buggy, how many chances do you think users will give you before they uninstall your applications? The number is quite low. So 80% of people will only use it like 3 times and uninstall it. It's a very high, a staggering high number. Overall, you'll see that the trend of people is that people are having very low tolerance with unstable or apps that perform not in a good way. That's the main trend for expectations. When we look at the operating system like iOS and Android, the restrictions have differed a lot. Back then, your app could eat a lot of memory, it could eat a lot of battery, eat CPU, or literally eat anything. Now, if your app does anything that misperforms, if it eats a lot of battery, eats CPU, memory, anything that takes a lot of resources, the iOS and Android systems will crash your app because it's misperforming. And with time, it's getting much more restrictive as well. About the landscape. So if we go back like 10 years ago, in 2012, for example, we had an active 500,000 applications on the iStore. So if you have a delivery app, probably you have 1 or 2 different competitors on the store. Now, if you have a delivery app, this number of the 500,000 applications are now 4.7 million apps. It's a 10x growth that's happening. If you have a delivery app back then that had 2 competitors, now you have around 15 or even 20 competitors that's happening. Finally, we will look at the ASO, or like the App Store optimizations. The App Store optimizations mean if you search, for example, for the word photos, how can you rank here? How can you rank like in the first place here? There were different factors that affected this. This is very similar to the idea of SEO when it comes to web. Back then, the factors were quite limited. There were like 3-4 factors, mainly if you have to optimize the app name, the keywords, the subtitles, you can hack your way into appearing like in the first place in the app or Play Store. Now things are quite different. Actually, the ranking factors are a lot. You have the ratings, the updates, the usage metrics, are people using your app or not, the reviews, the downloads, the uninstalls, and the keywords. But if you look here closely, you'll see that there is a good chunk of the metrics that affect your ranking in the App Store. It has to do with stability. So you have hang rates. How many times is your screen hanging? Do you have a good app launch speed or not? Do people terminate your application a lot or not? Like all of these things affect your place in the App Store a lot. This is when it comes to ASO. So as you see, performance is heavily affecting your appearance when it comes to the ranking. As a summary here, the trend is people are having very low tolerance, and looking at crash-free or crash rates is just one of a lot of things that you need to look for to have like a stable application. The summary is in 2020, performance is not just crash reporting. Performance is, we can say that it's two things. It's speed, which is like app launch, is your app loading quickly, is your app not hanging, plus stability, which is what we call in like lingo, normal lingo, which is like your app is not buggy, it does not have crashes, does not have bugs. So this is the trend. I will leave the rest of the key metrics for Anwar to walk you through what are the important pieces that you need to look for. Anwar?
Thank you so much, Magdoob. So as Magdoob was just mentioning earlier, performance was really about crashes. Now it's more an equation of speed and stability. So when you think about the top key metrics to measure for any new release, you will be thinking about measuring one of those metrics. So when it comes to speed, we really recommend focusing on those 4 metrics, which are the app launch, screen loading, UI responsiveness, and client-side network. And when it comes to stability, you should focus not only on crashes, but actually also on out-of-memory exceptions and the fatal hangs and ANRs. So I think we can just simply start with app launch. So first of all, what is app launch? Basically, app launch is the time your app is taking to become responsive and ready for your users to start using it. But why is app launch that important to measure? So as Magdoob mentioned previously, 80% of your users will only use the app maximum 3 times if they believe that it behaves poorly. So based on that, to be honest, if I'm going to recommend one metric for you guys to focus on as a start, it's going to be app launch. Why? Basically, because it's the first experience for your users. So you always need to have a very good first impression, as your users won't tolerate if your app is taking too much time, especially at the first time they just use it. And also if it crashes or something at the first time, then this will be a very, very bad thing to be. So you will need to focus on app launch a lot. Magdoob, if you can go back to the previous slide. Thank you. The second reason for why you should focus on app launch is basically it's a big factor in how Google and Apple Store rank applications in store searches. So you really need to focus on app launch. So what are app launch types? Basically, we have 3 types. We have cold app launch, we have warm app launch, and hot app launch or hot start. When it comes to cold app launch, this is when your app is launching from scratch. So this means the app process has not been created yet by the system. So the app is just starting for the first time since booting, or the app was killed before and then started again. So this usually is the slowest type of launches, because basically the process of the app wasn't exist before. So you usually will need to focus on this one because it's gonna have the longest launch time. The second one is, let's skip to hot start first because it's easier to be explained. So basically a hot start is when your app process is already running in the background. So in hot start, the system has some sort of process already running. So the application is already present in the memory. So it doesn't need to really initialize it again. So it should be much less overhead. And the warm start is only for Android, and it's something in between. So usually it has bigger time than cold app launch, but less time than hot app launch. So when it comes to definition of app launch, you think that this is very obvious, that everyone knows what app launch is. However, actually speaking, this is very interesting, as previously a lot of companies defined their app launch as the technical latency only, which is the time for the app to start accepting touch events. which actually isn't really useful. As from user perspective, if a user is seeing a loading spinner or a splash screen, they will still feel that the app didn't launch yet. So our recommendation here, and actually this is how a lot of other companies is defining app launch nowadays. So we have seen a lot of customers do this, and actually other companies in the market started to write articles about this new definition. Which is to include the total perceived time, which is actually a function of the technical app launch time. So this time to render the views, and also the time for any resources, any content you'll be fetching from the network, or any thing that you'll be fetching from the database. So that it's really the overall time until the actual content appears for your end users. So we really recommend you to redefine your app launch definition and start measuring it with this new definition. Okay, so some benchmarks here. When it comes to Google, they recommend app launch to be less than 5 seconds. And this is for cold app launch. And 1.5 seconds for hot app launch, and 2 seconds for warm app launch. However, when we look at the top 100 apps in the store, we'll find that 40% of them actually have an app launch less than 2 seconds, which is very, very interesting. And 70% of them just have an app launch less than 3 seconds. And based on that, I think we should you should be targeting an app launch time between 1.5 seconds to 2 seconds maximum. Because as you can see, this is a trend of the top apps, and you always need to be benchmarking yourself with apps like these. Okay, so some tips for monitoring and enhancing app launch latency. So first of all, monitoring the latency, you need to monitor all the first screens. So basically, most of the companies just focused on one screen, which is usually the home screen, but they've forgot about other screens. So if your app is using push notifications that launch a deep link to other screen or something, you need to start optimizing those screens as well. We don't recommend looking at them all, but just focus on those that has the high traffic and the most business values, and start optimizing those first, and then you can work on other first screens later. The second tip here is to split the latency of app launch into multiple stages. So usually stages here is going to be something like activity on start, activity on create, so life cycle activities. After splitting those, you will find that instead of having a bigger latency, you will have smaller problem, and you can identify this easier. And also, the next thing we recommend is to reduce the network calls on the critical launch path. So try to identify all the network requests that is happening during app launch, and try to execute those asynchronously, or just postpone calling them later or something. And also, it's a good idea always to cache data between sessions as much as you can, so that you can have the data needed for the users always without the need to go to the network and back. So this is a good advice. And lastly, try to move any expensive tasks that you're running on during the app launch critical stages, and focus only on things that are super, super critical for app launch. So next is screen loading. So what is screen loading? Basically, screen loading latency is the total time each screen takes to render. To render its views, its subviews, and to load any initial content in it. So if you think about it, it's really similar to app launch, but instead of measuring the time for the whole app to load, it's measuring the time for individual screens to load when navigating to them or something. So it's actually very, very similar. So most of the tips that we already shared for app launch should be working here as well. And usually when you debug both, it's going to be the same tools and the same things that you're going to look at. That's why we also recommend to have the same definition, which is not only to include the rendering time and to include the any blocking network resources inside the definition of screen loading. So when it comes to benchmarking, actually the initial views rendering time shouldn't take more than 500 milliseconds, because if it has more than that, the user will start wondering and feeling the delay. And when it comes to the content time, this shouldn't take more than 1 second. And this is if you already have a loading spinner or something, or a skeleton. So we recommend that the overall loading time shouldn't take more than 1.5 seconds. And this is basically based on initial surveys we are doing with our customers and some data points that we collect. So next is UI responsiveness. So what is UI responsiveness? Basically, when you think about UI responsiveness, you think about one or two things. The first thing is hitches, which is basically some frame drops that happen during a scroll or animation or transitions and shouldn't last a lot of time. So if you can see here in the GIF, you will find that while the animation is moving, it hitches a little bit, or in the scroll. So it's a tiny frame drops, which is basically something less severe, but commonly happen more. And we also have the hangs, which is which is more severe. And basically it's when the app is not responding for touch events for more than 250 milliseconds. So as you can see here, the user, if you clicked on something, you'll expect something to happen. And then if there is a delay, then this is a hang. So let's start first with hitches. The first thing we need to think about is how to measure hitches. Actually, you can't measure it by just calculating the total hitching time, because you can't compare between if the app run for 1 second versus 10 seconds if you just have the total hitching time. And also it really depends on the frame per second of the device itself. That's why for both hitches and hangs, you will see us recommending to normalize the metric first. So in hitches, the main metric that we recommend to use, and actually this is the same metric that Apple recommend as well, is using hitch time ratio, which is basically the sum of hitch time in millisecond per second for a given duration. So if you looked at those two examples, you will find the first one has no hitches at all, while for the second one, you will find that some frames is taking more time than expected. So if we counted all the total time frames, that is taking more than 16 milliseconds to be drawn. So this is the red lines in the second screenshot. We will have 100.02 milliseconds, giving this example. And also if we have 30 milliseconds and we have a device that's running on 60 frames per second, then the total duration here is going to be 0.5 seconds. So the total hitch time ratio is going to be 200.04 milliseconds per second. So is this a good or bad thing? So some benchmarks here is you will know that if a hitch time ratio is less than 5 milliseconds per second, then this is good. It's warning if it's between 5 and 10, and it's going to be critical if it's more than 10 milliseconds per second. So for our last example, definitely it's bad. Next, we have the UI hangs. So UI hangs is calculated with a metric called hang percentage, which is similar to what we did with hitches, but with slightly different equation. So first of all, we need to get the total visit duration, which we need to remove any idle time from it. And then we need to calculate the total hang time, which is, in this example, is 250 plus 300 plus 400, and divided by the total visit duration, which is in this example 10,000. So the total hang percentage is going to be 9.5%. Again, is this a good or bad number? So the benchmarks for hangs, it's going to be good if it's less than 2%. It's going to be warning for you if it's between 2 and 5, critical if it's more than 5%. So definitely this was a critical hang that you need to fix. So next we have network. And as you can see here, we didn't say network, we said client-side network. But let me go into this more a little bit. So when it comes to network, we need to look at mainly two things: network failures, which is divided to client-side and server-sides, and network latency. And actually, for most companies, they tend to monitor this only server-side, which is half of the story. So if you are using any backend service to monitor the latency and the failure of APIs, you will first miss the client-side failures, which, believe me when I say they are a lot. We have a lot of customers that started using Instabug for the first time, and they didn't measure the client-side failures before. And when they did, they were just surprised of how much they are missing out by only monitoring network server-side. Also, even the latency, a server-side monitoring tool will only capture latency when the request is received to the backend and until it's processed and sent back to the user, which is actually half of the story. There is a lot of the latency that the device have, and also network during the transition from the device to the server. So when you really think about it, if you are optimizing for your user experience, you need to look at the full story, which you will get only if you are monitoring it from the client side. So next, some tips and tricks in prioritizing network requests here. So you need to categorize your requests into two categories: key network requests and non-key requests. The key requests here are mainly all the requests that are very, very important for your users, like a login API or something. And then non-key requests that are not as important for user experience or not impacting the end users. So something like an API for analytics or a background API that is called while the user is using the app. So the goal here is to prioritize key requests first, as those are the ones that really affect your user's experience. So that's it with speed. Next will be stability. Makhdoom, I think you'll best talk about those.
Okay, thanks a lot, Anwar. So Anwar talked about speed. I'll cover the part about stability, which is about the crashes or the buggy part of the application. So we'll talk about three things. The first thing is crashes. We already, all of us know crashes, but let's dive a bit deep into it. So a crash, it happens when your app tries to do an invalid operation. Let's say it's dividing by 0. So the operating system decides to kill the application. It's as simple as this. Now, but not all crashes are equal. There are different types of crashes that happen. One of the worst crashes that happen is a crash that happens in your app launch. Let's say you're launching Toys R Us and a crash happened here. This is when we surveyed customers, this is the worst experience for them. They label an app as this is like the first impression, it's not working. So it's a crash, but when it's with the app launch, it's quite bad. The second severe type of crash, which is what we all usually see, it's called the foreground crash. Let's say you're sending a text, you're using an application, and suddenly it crashes. This is the second type of crashes. Another type of crashes, which is a little bit severe, it's called background crashes. What is a background crash? imagine, let's say you're using, for example, YouTube, and you have this video at a specific moment in the screen, let's say at a minute 3. Then someone sends you a message, so you put YouTube in the background and you open WhatsApp or any messaging tool. When you go back to open YouTube, you'll find that it's restarting. It's not opening from the same video that you opened. This happens when this happens because a background crash happens, which means that the operating system felt that YouTube is taking too much space or memory or doing a lot of processing, so it decides to crash the app. So when you open it again, you start from the experience from the beginning, which is a bad experience, but it's not as bad as having like a crash. So these are the main types of crashes. When it comes to benchmarking, as Anwar said, crashes have like different types of benchmarking. Mainly people look at the crash rate, which we talked about in the beginning, but the crash rate is quite different when it comes to different industries. This was a very good survey that was done on companies. It looked like B2B companies that work with like business to business. They mostly have a very low tolerance for crashes. It has to be 99.85, because if you are a business and your app crashes, you lose a customer that will pay you a lot of money. On the other hand, you'll find that something like the gaming industry, they have a higher tolerance for crashes, because usually what people found is that when you're playing a game, you are sticky to this game. You use it a lot, even if it crashes. So the industries change a lot, but the highest one is usually B2B and B2C like industries. This is when it comes to crashes. The other type of crashes, it's called out-of-memory exceptions. We noticed at Instabug these types of exceptions are very high. I'll give you an example of them. So what is an out-of-memory exception? It's exactly like a crash. As a user, you would feel that it's a crash. What happens is that if your app has like poor memory management and the app takes a lot of memory, the operating system decides to kill the app at the end. What we noticed is that out of memory, which is like an acronym for OOMs, so out of memory errors are 5 times more likely to happen. We noticed this when like a customer came to us and they told us, hey, our app store, like we have a very good crash-free rate. It's like 99.85, yet people come on the Play Store and they give us very bad reviews that the app is crashing. When we investigated this, we realized that they were not tracking the out-of-memory crashes. They're not tracking it by itself. So it's a type of crash that you have to track. Now, how can you decrease the out-of-memory crashes when you release a new application? There are 3 or 4 things that you can do that can help, definitely help. One of the main things is make sure that all of the images that you have are compressed. Images are one of the most, like the biggest objects that take up a lot of memory in the mobile. So this is an example image. It's like 900 kilobytes. After it's compressed, it's nearly like less 10 times than the original size. It looks the same, but the size is much lower. And try to do this automatically. Like connect this to a specific automation tool that does your images automatically, because if you sometimes release an app with a lot of big images, it can definitely crash your application and cause a catastrophe. This is out-of-memory crashes. The second type is to listen to something that's called memory warnings. So the operating system, especially iOS, when the operating system feels that your app is starting to take a lot of memory, it sends you a memory warning, like, hey, you're taking up a lot of memory. What you can do is listen and respond to these warnings. So if you get this warning, you can respond in your code that you can maybe like free up some cache or free memory objects and release them. So you have to have like a part of your code to handle all of the memory warnings. The second thing is, before releasing an app, you have to do local profiling. So Xcode has a lot of tools that you can do locally. that you can profile the user flow. What does this mean? It means that a user flow is, let's say, your Uber. A user flow would be to book a ride. So you would profile this whole flow of booking a ride from the moment that the person clicks on the button till the ride comes. And you profile the memory to see, are there any peaks that are happening in this user flow? So you should profile all of the main user flows for this new app version and make sure there is nothing that's not acting normally. Lastly, you should look at what's called peak memory. So this is an example graph that shows, so the x-axis has the different app versions here, and the top or the y-axis has what's called the peak memory. The peak memory is if you have a lot of sessions for a specific app version, what is the highest memory at any point in time that took up a lot of memory when it comes to iOS, for example. So this is the peak memory. You want to make sure that the peak memory, you compare it to different app versions, that this new app version is not higher than before. You should actually optimize to have it lower. All of this can be done locally or through beta testing. The final type of crashes we'll talk about is what's called fatal hangs and ANRs. So Anwar talked about hangs. There is different types of hangs. There is a spectrum of hangs. So it can hang for 250 milliseconds, or it can actually hang for 5 or 10 seconds. This is what we call a fatal hang or an ANR, which we'll get back to right away. What is an ANR, or an application not responding? Let's say this is your app. You're using it normally. You're scrolling, you're writing some text, and suddenly your app hanged for 5 seconds. It is like 3, 4, 5 seconds. Then you see this banner from Android: application not responding. Do you want to close the app or wait? When does this happen? This happens when your application hangs for 5 seconds and Android shows you this warning. You can either continue or exit the app. This is definitely a very bad experience that you need to track, and these are called ANRs. Now, what are the benchmarks for ANRs? Android has an official number for this. They say that if you have like 100 sessions, only 0.47% of your daily sessions should not exceed this number. You should optimize that all of the ANRs should be less than 0.47 or like 0.5% of your whole sessions. So if you have like 1,000 sessions, this number should be much lower as a percentage from this number. Now, how can you decrease ANRs? There are 2 main things that you need to focus on. The first thing would be avoid running any slow code on the main thread of the app. If you have any slow code, automatically do it into other threads or into other parallel threads. The same thing if you have any IO requests or like network requests, always do it into other threads, not into the main thread that the user is seeing, because it blocks the whole experience for the user. These are the main 2 points that you need to look for to have like a better or decrease the ANRs. Now, what are the fatal hangs? ANRs are specifically for Android. So fatal hangs, you can think of it as ANRs, but for iOS, and it's exactly the same experience and exactly the same way that you need to look for to decrease these hangs. So these were the 3 types of crashes to have a stable app. Anwar, I will leave the metrics North Star for you to walk the users for this part.
Thank you so much, Magdoob. So now, after we finished all the key metrics, the question now is, which metric of those should represent the quality of new releases and be like the North Star for each release? So short answer for this is all of the previous metrics. So like what Magdoob said in the beginning of the webinar, nowadays performance isn't just crash-free sessions. It's a combination of a lot of metrics that measure the speed and stability of your mobile app. So how can we combine all of these metrics to actually evaluate any new release? The answer is tricky. However, it's easy. So using aptX. So what is aptX? What is exactly aptX? Magdub, if you can go to the next slide, please. So aptX is an overall score, or it's a score that reflects the quality of your user experience. So it's just a number between 0 and 1. The higher the value, the closer you are to satisfy your end users. So for example, if you have an aptX of 0.95, it would be an excellent aptX score. However, if it's less than 0.5, then it's unacceptable. But how is this metric is really calculated? So if you can go to the next slide. So basically, aptX is calculated based on the number of satisfying sessions and the number of tolerable sessions divided the number of overall sessions. So the question here that we need to ask ourselves is how a session is defined as satisfying or frustrated. So basically, for each session, we can define its performance based on all the metrics that affected the user experience in this session. So for example, if a session ended with a crash, then it's a crashing session. It's the worst case experience. We will say that it affects everything. However, if the session didn't crash, but the app launch was slow and there is multiple frustrating network requests, and also there was a lot of hangs, then we will give it a score based on the number of or how frustrated is the user with the occurrences in this session. So for example, if you want your app launch to be 2 seconds and then the user have it in 2 seconds, then this is a satisfying app launch because it was less than the target that you were aiming for. However, if the app launch was between 2 seconds and 8 seconds, then it's bad. However, it's tolerable. It's still within range. But if the app launch is more than 8 seconds, then this is a frustrating app launch. So basically, you should do the same for each of all the interactions that the user is doing in these sessions. And based on the average number of tolerable sessions, tolerable occurrences versus frustrating occurrences, you will give a score to this session and say that this session was satisfying for the user, or it was tolerable for the user, or it was frustrating for the user. And based on this, you will be calculating the aptX score. So next. So how to use aptX? Basically, the first and the most important thing that you can use aptX for is actually to set targets for new releases. So by default, your new releases performance should only increase or maintain. But if you will see a decline in the aptX score over time, then there is an issue that you need to focus on. Your releases nowadays is not as good as before, and you need to act quickly. Maybe you will need to roll back to a previous app version. Maybe you will just need to disable a feature flag that will disable the feature that's affecting the quality over there, or just start digging and see the issues that affected the aptX score. So this is one of the main use cases for aptX. The next one is to balance between feature development and performance improving. So basically, this should look obvious. However, it's very, 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 very tricky for a company to decide to invest in performance. Usually, I'm a product manager and I know this. I always need to have new features running in engineering teams. It's very difficult for me to decide that I need to sacrifice new features and start improving the performance. But having aptX score as a metric can align all the company in one direction. So if the aptX score for our releases is more than 0.95, then we are good. We can develop new features. We don't need to worry about the performance right now. However, if the aptX score is between 0.5 and 0.7, then this is a poor quality app. We need to pause everything and just dedicate all our engineering teams to focus on performance improvements. So actually, this is one of the main use cases that you can use aptX for as well. So I think that's it from our side. So back to you, Julie. Thank you so much.
Awesome. Well, thank you both. I think we have a few minutes to answer a couple questions that came in from the audience. And if there are any other questions, please send those in and we'll do our best to get to them. The first question is, have you ever experienced that the iOS crashes are not sent to Instabug or Crashlytics?
Yes, I can answer this one. So this usually happens, like when we observed this with customers, this usually happens specifically on iOS and not Android when you use like two different crash reporters at the same time. So when you use two different crash reporters at the same time, let's say it's Instabug, it's Crashlytics, it's another tool. If you use more than one, usually there is a lot of conflict. So the iOS, it tries to just optimize for one crash reporter that's being used. So many crashes can be dropped if you use two crash reporters. So it's always recommended specifically for iOS to only use one crash reporter. However, for Android, it's completely okay. You can use up to 7 or 8 crash reporters at the same time.
Awesome. Thank you, Mahdoob. Another question that came in is, how do you monitor socket-based applications?
Okay, so I can take this as well. So it's very tricky because socket-based application, you will need to, if you have a socket-based application, definitely you will use it in some way that you will need response time to be as fast as possible. So you still need to measure the performance of this. There's tools out there to track the time for this. So I think maybe we can take this offline or something, and I can elaborate more on this question if you want.
Perfect. Another question that came in, what is the frequency of reporting on your dashboards?
It really depends on what product you're asking on, but for crash reporting, I think it's real time, right, Mahdoob?
Yes, it's real time. So for crash reporting, I can explain a bit more this part. So when we receive a crash, let's say it's Instabug, we receive a crash, it's in real time. But let's define what does this mean. Let's say I'm using the application as a user and it crashed with me. Currently, the crash does not get sent right away. It gets sent when the app is opened again. This is how all crash reporters work, because when it crashes, you cannot send any data to the application, whether it's like Instabug or other applications. So it happens when the user opens the app again, which is usually what we observed is usually in the same minute, because it crashes. So you think something is wrong, so you have to open it again. So it's very close to real time. Yes. This is for crash reporting.
Yeah, and from the other performance metrics, we have some sort of sync interval to collect data offline and then send it in batches once each 6 hours. And this is just to save the bandwidth of end users and don't send a lot of network connections. So it's once each 6 hours.
Perfect. The next question that came in is, what resources would you recommend to find users to test your beta app?
Actually, this is very, very interesting. So I recommend you go to instabug.com/blog. You will find a category for beta testing. There is a lot of articles talking about this topic. And I think we have a lot of resources in this field.
Awesome. Well, those are all the questions that came in, and thank you for everyone that joined us today and all the wonderful questions that were sent in. Just as a reminder, this webinar was recorded and will be sent out and will be available for you to review afterwards, along with our APM guide. So I just wanted to thank you again, Magdub and Anwar, for all your insights, and thank you for everyone who attended. Have a good rest of the day.
Thank you, everyone. Have a great day. Bye.